So welcome everyone. So I think we should start with a round of introductions. My name is Zach Shelby. I'm one of the board of director members of the tinyML Foundation. I'm really happy to help host our breakouts here at the tinyML Summit. So we have a really exciting breakout for today. We are talking about market applications and growth in tinyML. Where's the business going to be in tinyML? Where we're going to see really interesting vertical applications, technologies, et cetera, that are going to bring growth and exciting new things to this industry. And with us, we have Michael Azoff. So Michael is the lead analyst at Kisaco Research. There's a lot of experience in how these markets grow, and he's been digging into the edge AI market, and he's going to tell us about what's happening. We also have with us Lee Carter. Lee is a principal with Momenta Ventures and has experience in investing in startups in the space and kind of what's hot. And they just have started a new fund around AI and IoT. So I think it's great to have Lee on board with us. So thanks, guys, for joining and running this session. Michael, I'll leave it with you.
Hey, thanks very much for the introduction, Zach. Hi, everybody. Welcome to this session. As Zach introduced myself, I'm Chief Analyst at Kisaco. If you've not heard of us, we run events as well, AI Hardware Summit and Edge AI. And I'm the analyst wing of the company. So welcome. And Lee, good to have you on this session as well. So my first question for the panel is how shall we define the edge for the purposes of this discussion that we're having? So how would you like to do that? Zach, do you want to start?
Yeah, sure. I think it's actually a really, really important question as this market develops. You know, us here in the tinyML community, we've kind of started out looking at very low power hardware, right? Under a milliwatt of power consumption while we're running ML inference. So that's kind of what the tinyML community has thought about as the edge so far. But if you look at the wider market, we see edge as a kind of pretty watered down term. A lot of people are looking at edge compute as kind of everything from microcontrollers that run at low power all the way up to edge servers and 5G base station compute centers and some really, really kind of almost cloud data center style infrastructure. I think talking about embedded compute is really helpful when we talk about edge. So when we talk about what we like to consider as like the compute targets that are really useful for machine learning with real industrial applications, for example, we talk about embedded compute. And for me, that means everything from low-end microcontrollers up to kind of the NVIDIA Jetson, right? That's that kind of scale of embedded. So it's edge, but it's a little bit narrower on the headless devices deployed in the field.
Okay, very good. And Lee, do you have any thoughts on as an investor, what do you look for when how you're defining the edge?
Yeah, I mean, I think when we look at it, there's kind of three levels to it. There's sorry, I'm talking. So when we look at it, there's kind of three levels to the edge. There's the embedded edge, which is what we generally talk about when looking at tinyML. When we look at an edge impulse in the places that I think we're mostly talking about today. And then there's the gateway edge for IoT deployments, where where you're sending data back, where your major backhaul is, and where you can have a lot of intelligence if you're going to group assets in a particular location and do intelligence on those. And then, like Zach said, there's the server edge, where you're doing kind of major calculations, but you're not actually bringing things to a let's say a wider cloud, if you will. And so sometimes that's on a single location. Sometimes there'll be a distributed compute factor to that. But when I think about the edge intelligence,
on this Sorry, guys, can you please mute yourselves?
and when I think about kind of what we're talking about during this entire summit, a lot of it is really that embedded intelligence, like Zach was talking about, at the device level itself, before you have to send it back to any other space.
Right. And given that this event is tinyML, I
Yeah.
think it's actually worth also talking about differentiation at the very, very small edge. Um, some edge devices will be battery powered and will run for a year without being connected to any other system. Um, and other edge devices will always be wired. And I think given the availability of technology that can run on very, very low power, I think we can start creating categories within that very low power range. So maybe this is something that we'll be writing about, but certainly there is no standard definitions for that very small edge, and I think it's worth delving deeper into that so that people are clear exactly what kind of devices are possible, because there are many, many grades now possible, available at the very, very low power edge. So let's talk a little bit about the AI business market trends for both edge and edge AI. Any thoughts about what you're seeing on the business side? So let's start with Lee this time.
Yeah, sure. So I think a big piece in this has been the increase in availability and ability to execute on low power wide area networks, and how they can enable new applications. And so when you look at this space, there's two major things that have been a detractor from the ability to roll out applications, and that's network coverage and the ability, basically the ease of use to build ease of building an application. So how simple is the application stack for developing a battery powered sensor on the edge? And so for us, we've noticed over the past 10 years that both of these things have gotten much, much better, whether that's NB-IoT coverage, a proliferation in LoRaWAN type networks, or the coverage that Sigfox has provided as well. That's kind of started to get us in a place where there's actual network coverage for these things. And then it's a lot, so much, I mean, compared this year to 5 years ago, the ability to create a application on those networks is far simpler. And so that is a trend that has made it more possible to do these things. And then when you add the battery requirements of computing right now, the decrease in battery requirements for different types of microcontrollers, that's led to a proliferation of new applications and to what we're talking about now, which is this tinyML idea where you can actually have intelligence at the edge, where you're looking through a camera, you're listening to some audio, but you distill that information into simple things that can be sent over those low power networks. So that's the main trends that we see. That's, to be open, we are investors in Edge Impulse and like what they're doing, and that's kind of part of that thesis around these things are actually possible, and Edge Impulse and tinyML in general makes a 10x difference in what types of things are possible there.
Very good, thank you. Zach, do you want to give your thoughts on that?
Yeah, I think the LPWAN angle and the low power networking angle here in general is a really good point, because what we see driving the adoption of tinyML in real applications is either constraints in battery, right, which Michael's already mentioned. This power factor is really important. If you've got a battery constraint, tinyML can have huge impacts on battery savings while you're churning through all this data, because you don't have to turn on the radio in the first place. And radios are expensive when it comes to power. So sending less information around the world is going to save power, and that's something that you can apply tinyML to help you with. So there's a battery constraint. We're seeing communication constraints, right? Where often the amount of information we need to process, right? Complex accelerometer data, for example, is too much to send over the network, or that's too expensive. So this is where it's a really great match with LPWANs, right? Very low power, very long range, low bandwidth networks are highly compatible with tinyML. And then the third thing that we see driving this is cost, right? We see big improvements in the cost price points of where you can execute these kinds of machine learning algorithms, so where you can detect complex patterns. And tinyML is matching its way into the microcontroller world, right? Where very inexpensive, very low power devices. This is kind of like the holy trinity of tinyML: battery, communications, and this cost factor. These three things are driving the market. But I actually have one slide I'll share with you, since we'll make this a little bit more graphical, if you don't mind, Michael.
Yes, please.
We did a really interesting analysis of the market late last year. I'm gonna show this in full screen. This looks okay?
Yep.
Great. So we did a real data-driven analysis of the market late last year. We looked at the top requests that we see in the industry, right? Real customer cases coming our way. And we ranked the top 60 pipeline requests, so the top 60 opportunities and customer cases. And we did a kind of data-driven analysis to group them in the top 3 applications that we're seeing. So this covers about 80% of all applications that come in towards us. And that the most popular things are predictive maintenance applications for tinyML. So working with motion, current, audio, and cameras to some extent. But I'd say that the sensor side of the market is still the most common. And so this is things like industrial predictive maintenance in white goods, smart grid and water infrastructures, as well as automotive applications. Second area that was very popular is asset tracking and monitoring. So that's not only accelerometers, but also temperature, humidity, position even, along with audio and computer vision. So this is tracking packages, tracking vaccines, as well as things like building occupancy detection. So people in buildings returning to work, big application at the moment. And then finally, we're seeing a lot of things around human and animal sensing. So wearable health devices, safety devices, as well as agricultural animal tracking solutions. So this starts to add things like radars for gesture interfaces, keyword detection with audio, as well as human sensors like ECG or EEG, right, can be processed with tinyML.
I think, Zach, to just add to that on the slide that you still have, actually, the piece that I think is interesting is also that in LP WAN there's and what we're discussing a lot in this tinyML summit is the low power constraint, but the other part of that phrase is the wide area piece and the ability to put sensors in all kinds of different places. When you look at your slide here, you have infrastructure, which tends to be very large implementations, health, where you're tracking people in a particular campus environment or something like that. All of this is a relatively new market trend that's actually possible with low power devices in these wide networked areas. And I think that when you combine those types of things with embedded intelligence, as we were talking about, it's wildly powerful. So,
Thanks for sharing. Maybe if I mention at this point, and I don't know if I can share my screen, but I've got a slide here from LF Edge. So Linux Foundation Edge is a non-profit part of the Linux Foundation. A lot of industries subscribe to it, so it's pan-industry. And they create, they run a number of projects, but they also have some literature. And they ran a survey on what they called IoT killer apps. So some of this will obviously be relevant for our Edge. They see smart cities and smart buildings as actually trending down. And they see the fastest growth is in retail, but the biggest market share is manufacturing and industry and transportation and mobility. Any thoughts on that, Zach? Do you want to share anything?
Yeah, I mean, we're certainly seeing a lot of industrial applications, and so that matches what we see in the market. And I think that's because there's just so many custom ways that data can be applied. You know, the way we're seeing this from the customer's point of view is that tinyML is giving the customer a data-driven approach to solve their problems, right? This is no longer about like the OEM deciding the one way to solve the problem for everyone in the world. That's typically how we built our systems in the past. We are seeing people get interested to apply data to solve these problems in a very data-driven way. And that gets into so many custom things in manufacturing. You know, we've had automobile manufacturers come to us wanting to do very, very specific manufacturing debugging using these small tinyML cameras, for example. Lots of things in industrial systems where you want to detect really specific faults, right?
Yeah.
When the electric current in this line goes up like this, or when this machine starts to vibrate like this, or if we hear this sound, right? This means something to the people running these facilities. And so that matches what we see. Lots and lots happening in industrial and manufacturing more broadly. And the same with transportation, right? And it's not just cars, right? We're seeing this with all kinds of last mile transportation systems. Lots going on there. We're seeing tinyML be applied. So sure. And energy, definitely, right? Energy, we are seeing a lot of activities. For example, we have a smart grid use case that we recently published, doing better monitoring of the smart grid using tinyML.
Right. Lee, do you want to share your thoughts on can you all see this slide?
Yeah.
Okay, brilliant.
Yeah, so I mean, I think, as Zach said, manufacturing and industrial is something that we've seen as well as being something that's leading in this space and something that has grown. I think, to be honest, I think this chart can be somewhat tough to look at on the smart buildings and cities, just because this is a 2020 chart and those things just got kind of pushed back due to obvious reasons. Because we've seen quite a bit in the smart building, smart city space come up in the past, I would say 6 months, when it comes to occupancy detection and parking detection, all these types of things that, to be honest, for 6 to 9 months of 2020 did not really matter that much because people just weren't doing that, and now people are putting those in place. So I do think that the smart cities and buildings is still going to grow over the next 5 to 10 years quite a bit. But manufacturing, transportation, energy, these are all places that we've seen huge growth and continued growth. And I think Zach kind of said it very well, but there's so much you can do here. I think an interesting thing that you kind of did by showing this slide is how the IoT killer apps, I do think are fairly close to what we probably see as the killer apps in tinyML, because that's just the applicability of tinyML it's applicable to anything that IoT touches, because it basically just makes it so you can have smaller, smarter sensors anywhere. And so that I think is important to note there as well.
Right.
But there's one key, before jumping into that, I think there is one key difference that we all have to keep in mind when we're going from IoT systems to tinyML solutions, is that the nice thing about machine learning is it's very standalone. Yes, we do a lot of data collection in the cloud. We build large data sets. We have a lot of machinery around creating these machine learning models. But when we go and deploy a machine learning model on an edge device, it's just there. It doesn't have dependencies across the huge system. It does its job, right? You feed data in, it gives you probabilities out. You might actuate something or do something locally. You might send that to the cloud. But it doesn't have like this long chain of dependencies that we see in IoT systems. And I came from the IoT space with my previous startup. We had nightmares of system integration, right? End to end in these large systems, and that kind of slowed down the market. And the cool thing of tinyML, you can think of it as a component of some IoT systems, but it can be deployed as just a single thing, right? It can be a single device that does its one job in a smart building. Whereas I think where some of the city and smart building applications have taken a hit is because they're such complicated systems, right? Trying to build an entire smart city all at once, like some cities in the world have tried to do, it's a nightmare of system integration. And I don't think we have the same kind of system integration nightmares in the tinyML world. That's really nice. We'll even see tinyML deployed in spaces where there is no internet, right? Just purely embedded systems where we want to detect something locally without sending it to the cloud. That's perfectly fine application for tinyML.
Yeah, very interesting observations. Thank you. So I'd like to show this is a various publicly available total addressable market for the edge computing and various numbers. So if we look at the dates, there seem to be 2017 to 2019, and they vary from 1.3 billion to 1.7 billion estimates of how it was at that time. And the projections go on to 28 billion by 2025, 15 billion. That's 15.8 billion. There's a B missing there. Second from the bottom by 2026. There's one outlier, McKinsey. They think it's going to be 200 billion by 2023-25. But the consensus seems to be an order of magnitude less. Any thoughts on these numbers? I know. Lee, do you want to start? Is this the sort of numbers that you calculate as an investor?
Yeah, I mean they're all somewhat close in range in that space. I think the trouble with this, I think, is in some cases, as we started this conversation, the edge computing market is defined differently by different people. And so whether you're talking about if you're talking about local servers being the edge, that's very different from talking about the embedded ML market. So it's tough to kind of like if we're overall defining it, that can be tough. But this is generally where we see it, and we do. I think what all of these show when you show the TAM at data and the projection is the growth. That's kind of the thing that sticks out. The ending number, nobody knows what the actual market size in 2025 will be, but the growth that you see is very real, and we clearly believe it will happen given our kind of new fund focused on this. I think the enabling technologies like tinyML and the ability to have sensors in all kinds of different places, like Zach was just describing, and making it fairly simple to do so means that the ability to do things at the edge, whether that's the sensor edge, gateway edge, server edge, wherever, is going to grow in a significant way. And I think that's what this table here shows fairly well.
Yeah, and I definitely see this as like minimums. So what we're realizing is that because tinyML is about bringing value to the industrial process, right, or to the logistics solution, it's not really so tied to the hardware or the edge compute, right? So something that we're experiencing is that the value is not about the BOM cost of the device, right? It's not about how much the hardware costs. So if you're selling hardware, you might get pulled into that to some extent. However, right, a lot of these solutions, when we're bringing ML into play, are software system solutions that we're becoming part of. So we have to look at the bigger system market. And when we've looked at the system market for these markets that we just looked at a moment ago, industrial, asset tracking and logistics systems, et cetera, that's a $140 billion market today. The kinds of systems that ABB and Siemens put together and provide for customers in these spaces. And tinyML is part of that, right? That's part of the value that we're helping generate, is doing more for customers, right? By using data to drive and detect really interesting patterns for them that can solve problems for them that are extremely valuable, right? These might be problems that are worth tens of millions of dollars a pop. And we should think about the value that we can generate from there. And that's value that the enterprise could create for themselves by using tinyML. It could also be value that an OEM can provide by providing a vertical application, right? A system solution for that enterprise. There's different ways to go at value, but I'd look at the bigger value. So 140 billion is what we see from a system point of view. Microsoft recently published their own report showing that the edge AI market more broadly would grow to become a $250 billion market in the next 5 years. And that about $70 billion of that is hardware. So $180 billion software market for edge AI. So we do have some people looking at this as a bigger system value of 100 to 200 billion dollars, not that far off from McKinsey. So it is getting interesting, but But yeah, Lee's right. It's growth, right? We're going to see growing from low digit billions to double digit billions at the minimum in the following years.
Right. Okay. So I think we're all agreed that there's going to be growth. And another comment, another view that I see a lot is that once 5G is rolled out ubiquitously, the edge is going to be a much bigger um, compute a market than the cloud, which is I think really interesting. I'll just share one. I mean, about some of these rather larger numbers. I do recall when IoT and M2M was the big thing, and some of the analyst firms, dare I say, from my part of the world, but not my firm, one of the bigger ones, talked about $1 trillion market. And I went to an event in London, IoT M2M event, and I discussed it with the various vendors that were exhibiting, and they all shook their head. They were really unhappy. It was not a helpful forecast. So sometimes the numbers are too big that come out from some pundits. But I think we're all agreed that there is going to be a growth in the market, and it is also going to outgrow the cloud. So these are sort of projections for the next 5 years. Can I ask you, what do you see? How do you see the world in 10 years from now? Is it going to be just more of the same, or is it going to be a real difference that the edge, and especially edge AI, is going to make? So I don't know, Zach, do you want to start this one?
Sure. I think the most interesting observation I've had from this entire space is that when we're dealing with machine learning in edge industrial professional systems, right? It's not about ML at all. And I think this is a really important point, right? Machine learning, when we're dealing with AI systems in the cloud, it's oftentimes about the machine learning, right? The machine learning is the product. Oh, we sell facial recognition systems, or we do bounding boxes around penguins and video feeds, or we're doing some magical keyword voice detection. AI is the product. But when you look at what machine learning does for industrial systems, it's something much bigger, right? ML starts to enable us to take this data-driven engineering approach to solve real problems with data. ML just happens to be the tool that lets us do that. But fundamentally, it changes all engineering and all development in every enterprise, right? They can start to take advantage of this to drive the way they innovate. And then it becomes part of our engineering development toolkit, right? And that's a much bigger thing. And that's my vision for 10 years out, right? This becomes a standard part of every developer and every engineer's toolkit. Oh, I have data to go along with this problem. Great. Let's apply some ML to this. Let's use that data. Let's help that drive the algorithm. And then let's write a bunch of code around that, all the traditional development work that we do today. And that's a game changer, right? That means our tinyML becomes part of every developer's toolkit, and that's exciting.
All right, very nice. Lee, do you have a vision for 10 years from now for Edge, and especially Edge AI?
Yeah, I mean, I think Zach's point on how developers interact with it is spot on, and so I wouldn't change much from that point of view. I think what I envision in the next 5 to 10 years, and maybe even sooner, is also the ability for anyone within an organization, especially the IT operators and the operator and business line owners, to be able to take some of that into their own control without even developer involvement. And so, not to take developers out of the equation. Developers will always be the people who run the show on large swaths of operations. But I think you'll be able to have somebody in a decision-making capacity, or maybe somebody that is their right-hand person or whatever, able to go and do some type of analytics on some of the low-code, no-code type platforms we're looking at, to be able to utilize all this information in a decision-making way that we haven't been able to do in the past. just through kind of these types of platforms that are coming out, making this easier to use. And so when you have the tinyML broadening to make data more ubiquitous and have more data coming out of the edge, that will enable new types of business workflows that haven't been done before. And so that's where I see kind of a major innovation happening as well. In addition to, I do agree with Zach on developers being able to have that data-driven workflow as well.
Right, very, very interesting. And I mean, clearly, tinyML is very much about ease of use, isn't it? And it's creating a platform that makes it much more accessible for software developers to work with embedded devices. And just thinking while you were voicing these views, Lee, that maybe AI, 10 years from now, will be part of that, making, the low code, no code, making it easier to code these systems through the developers working through AI to actually create the code.
I think that's
Go on.
certainly part of it. I mean, I think that goes to Zach's kind of vision around data-driven development and how you can actually utilize that to make coding simpler and more efficient.
Right. Okay, so I'm gonna see whether we've got any questions from the audience. So let's have a look.
I have one that's coming on chat, so we can open
Yes.
up with that. It's an
All
interesting
right.
one. So we have a question. Why are companies like Google creating tinyML open source frameworks like TensorFlow, Lite, Micro, and why are they just giving them away as open source? Like, what do these companies expect to profit from, maintaining an open source project like TensorFlow? It's actually a really interesting question about the ecosystem and how this works, and that might not be obvious to everyone. Who wants
Yes.
to take that?
All right. Well, I think that is a great question. Who wants to start? I have my view.
Yeah,
Should I
sure.
start? Or is that Lee? Lee, go ahead.
Go ahead, Michael. I'm curious.
All right. So I think this is so I've been working with the AI and neural networks since '86 when backpropagation became the big news, and so I go back quite a while, and back in those days, the community was quite secretive. And if you wanted access to academic papers, for example, you had to be a subscriber to the various journals, and it was, there was a cost gate. It is ever so different now. The community, the AI community, is just so open. They don't only just share the papers, but they share code on GitHub. It's just so transformational, and I believe it is truly accelerating the rate and pace of progress in AI. And I think Google is playing its part in that. It is part of that community. But it isn't just Google that's doing it. I mean, through their influence, TensorFlow clearly has become a key development environment. But there's a lot of other key players in the market contributing, and I think it's this whole way of which the AI community has become more open, and I think it's part of that cultural change as much as any one individual company making a contribution. So that's kind of sort of long-term view that I've witnessed. But I don't know, Leo, Zach, do you want to give your views? Lee, do you want to start?
Yeah, sure. So I mean, I think from my view, this is, I mean, you mentioned it from the AI point of view. From my experience, this is also the trend in just software in general, right? And even some in hardware cases as well. And that contributing to open source projects gives companies like Google and others a name in the space and some reputability, and also gives them a potential onboarding for their other products where they make their money. And so I think in this one, it's getting people into GCP, being a company in the market that is on the edge. Using the word edge is kind of tough here, but who is on new technology and and something that people are looking for. Because like we just talked about with the market size, we don't necessarily know how big the market is getting, but we know it's growing. And so these types of companies want to be a part of that. And so if they're building open source that can enable people to utilize their platforms better, it may help them use competitors' platforms, but as long as they're kind of part of it and making a name for themselves, I think that is kind of where they want to be playing and what really helps them the most.
Yeah, and we all have to remember that digitization of traditional industries is the driving force behind the cloud and the internet. And this is something that Google, Microsoft, Amazon, Apple all have to help progress, right? This digitalization and machine learning tooling is part of that journey, right? Enabling more people to apply machine learning enables more compute, enables more digital solutions. I think that's like the fundamental driving force behind all of these open machine learning frameworks is that driving towards mass scale digitization. We also have to remember that Google is its own customer, right? So a lot of what Google uses from, for example, the TensorFlow community, it's driving their own machine learning efforts, right? Because they apply machine learning in many, many, many places, from hardware and Nest devices to wearables, right? To smartphones, to internet search. So a lot of the people at Google need access to this technology. Keeping that open and sharing it with the research community is really healthy for that, right? They also get access to some of the latest research, and the researchers get access to Google's latest work. So it is a very much about sharing. I know at least for us at Edge Impulse, we are heavy users of TensorFlow, the whole spectrum of TensorFlow, all the way down to TensorFlow Lite Micro. And we really like the community as a set of tools because it attracts the silicon vendors. Silicon vendors want to improve their performance of TensorFlow Lite Micro, so they contribute operators. We can make use of those operators to improve what we do, and we can also contribute back to that and contribute back to the community. So it just helps us, share a common set of math operators across the wider community, and that's healthy, right? We're not reinventing the stack every time that we work with a new piece of silicon or every time there's a new operator or a new architecture that comes through, because that kind of fragmentation holds back the market. So it helps us to kind of defragment as well all the shared pieces of technology.
Yeah, to add to that, I was listening to the VC panel before this in the tinyML Summit, and they were talking about new technologies and the ecosystem growth around them and how that's enabled. And so there's more and more lately, you've seen a lot of ecosystem growth come from open source projects where everyone can get on the same page onto the basics of whatever you're building, whether it's embedded ML or I don't know, a blockchain protocol or whatever you want to look at. And so that is where you see that happen, and then you get companies like Zax that make it simpler to use. You get and you do the whole process through it. You get vertical applications, and you can start to build up from there. And that's kind of where we're at in this community. And so for large companies like Google, it's not necessarily the right move to try to do something insular rather than be a part of that growing community and building that ecosystem up.
Right.
We have another
great responses.
Right.
Go ahead, Zach.
We're ready. Yeah. So from Peter, great that we're moving decision making towards endpoint autonomy. What are the opportunities for cybersecurity when we do that? And I bet you there's a few different ways we could slice this question, but I do think it's a really interesting one. So tinyML is moving autonomy to the edge. What is that going to do for cybersecurity? Where are the opportunities in that?
Right. Okay. So let me make a starting point. So one of the nice things about the edge is that you can keep the data local, and you can basically filter out a lot of personal details at a point where it's not going to be seen or used by the wider world. So as opposed to sending data to the cloud, you're keeping it local, you're making use of it for on a need basis, and you can strip it of any personal um, personal information. So in that sense, I think the edge is going to enhance privacy. Um, so as long as the technology is used properly, then I think that the edge can play its part in that and can give more comfort for people who are not comfortable with sending a lot of data to the cloud. I do want to point out that there is we talked about what's going to happen in the next 10 years, and I think we're going to see a lot more of secure. Data is secure at rest. Data is secure in transit. We're going to see data secure during computation. We are going to see that in the next 10 years. And that's going to be truly, truly transformational in regards to security. And that will have an impact throughout the whole spectrum from the edge and to the cloud, where everything is encrypted, even when you're using the data. So watch this space. But certainly for now, I think Edge benefits privacy. So, Zach, do you want to answer?
Yeah, the privacy issue is a great one, right? I do think we're going to see a lot of really innovative work. I do know there are startups doing like health privacy with ML on mobile phones. So they try to make sure that you're not actually sharing more about your health than necessary using ML. Really interesting. That's called Doc AI. I think we're going to see tiny machine learning used as a security detection and monitoring solution. I think that's going to be a big opportunity. You know, we're producing a lot of information on device statistics, right? Networking statistics. And we can apply machine learning algorithms to learn what are normal patterns of statistics and usage, what are normal network patterns, right? Versus something that looks like an anomaly or a potential threat, and identify those things right at the edge, right where they're happening, right? Rather than doing that indirectly with logs like we do today. So that's a big opportunity. I also think we're going to see more attention put on the security of the ML itself. I think this is a really fascinating field. You know, we already do work today on signatures of data going into data sets. So every time we collect a little sensor sample package, we sign it in a way that's immutable. So you're able to tell in the future whether that data has been manipulated, typically by accident, right? It's not necessarily even intentional. And that data set poisoning can cause big problems in your data set integrity and how your model performs. So this whole area of, you know, the security of the data going in data sets, I think is interesting. I also think we're going to see a lot of work going into securing the models moving to devices. Today, it's kind of part of the firmware process, but as we get into more complicated update mechanisms, you may need to secure the model itself. And then, as Michael, as you just mentioned, right, the compute execution, right, of that model, that's a weak point, right? If you have access to the device, you can see how that's being executed. Or even worse, if you get access to that model in the first place, then we're in big trouble, because then you have a black box attack approach where you can just put the model in a nice place and attack it with every permutation of input and understand how you can manipulate that model then in real life. And so a lot of interesting things are going to go on and change because of ML technology too.
Yeah. Zach?
Yeah, I mean, I think the piece that I wanted to mention, and I think that's an interesting. I think using tinyML as a security detection is super interesting and something that I think we'll see a lot more of. But the one that I've seen a lot is hybrid network models, and how do you secure or how to make something secure such that so when we looked at the markets, the two biggest ones were manufacturing and then logistics, right? Those two can actually be combined, where you have OEMs creating things and then they're sending them somewhere else, and then the OEM wants data, the manufacturing plant that they sent a machine to wants data, and the manufacturing plant may only want an on-premise solution. And so with tinyML in those edge devices, you can actually figure out you can actually figure out where the permissions lie, when those permissions changed based on location or time or anything like that. And how do you go from having an on-premise network that is totally insular to logistics network that you're doing through a third-party carrier? And so being able to decide those, being able to decide different networks and how secure each one is, I think is a really interesting space for these the embedded intelligence as well.
Great, thanks so much. So we've got 2 minutes. um, I I want to have your views on AI itself, and if you want to share your views of where we are on that journey towards that sort of ultimate goal of having human equivalent intelligence in an artificial machine. Do you have any thoughts on that you'd like to share with us, Zach?
Oh, you're gonna love mine. I think it's total BS. I spent over 20 years as an engineer building real systems with this technology, and we're crafting systems as humans to solve problems. We're transferring knowledge that we've built up expertise in. We're transferring that knowledge to computer systems. So my favorite saying is that if someone's talking about AI in a PowerPoint slide, it's probably AI. It's probably not really too real, right? So if you're just talking about it in PowerPoint, it's AI. It's probably an imaginary future where there's some super intelligence. Really, what's behind the scenes is a lot of hard engineering, right? A lot of logic pushed around a little bit of machine learning to create these systems that seem magical. When people talk about machine learning, they're probably talking about that real transfer of data-driven training of algorithms. And that's just training human knowledge, expertise into these models. And I think that's the real deal. I really think that's the future of machine learning and AI technology is very practical engineered solutions that transfer that knowledge. And with lots of railguards around it to make sure that it does what we want it to.
That's an interesting view. Lee, do you, what
Yeah,
are your views?
I mean, I've always had because we are really focused on industrial. There's been an interesting how to compare between where we are in AI to like what we think the future could be in general AI. Because I mean, in certain situations, like Zach was talking about, not interconnected, far off sensors that are in a far off place that are doing something that humans just couldn't do. Like that, like you're not really comparing to human intelligence. You're comparing to something that's completely new versus what I was referring to earlier around designing platforms around human-based decision making, which I think in that space we've gotten a lot closer to what you would call general AI. But I think in terms of what kind of the future is, I think more and more of these applications can do more things. So when you look at, we didn't even really talk about audio sensing, but when you look at those types of things, that's where we're doing more and more in the ability to replicate human processes, but not. I mean, I can't tell you how far we are on that journey or how far we have to go. That's for PhDs to study. I don't know.
All right. Well, thanks so much. I'll just say that I'm a technology optimist. We are very much on a journey, in my view. And but as I say, I'm an optimist. If you want to know more about my views, please get back in touch with me. Zach, thank you so much. Lee, thank you so much. Really enjoyed talking with you. Thank you, audience, for your questions. And sorry for the hiccups at the beginning. Enjoy the rest of your day. Thank you all. Bye-bye.
Again, just a quick shout out to our sponsors. Bear with me for 1 minute. We have different categories. We have executive sponsors. First one being ARM. Then we have Qualcomm. We have Samsung. Platinum sponsors. Ada Compute. Lattice Semiconductor. Gold sponsors, BrainChip, Babel Labs, DSP Group, Edge Impulse, EMSA, Gray Matter Labs, Greenwaves, Hymax, Imagimob, Latent AI, Maxim Integrated, Quixo, Reality AI, SensiML, Silicon Labs, Sentient, Google TensorFlow, XMOS, and lastly, silver sponsors, Edge Cortex, Hotchi, and Synsets.